1, Part 3. Chemical properties. So chemical properties refers to the ability of a substance to undergo a change that alters its identity. In other words, it's not going to be the same after it goes through a chemical reaction. Examples of chemical properties are the conditions under which paper burns. So, for instance, how much oxygen does it require? What temperature does it need to be in? And paper burns, and iron nails rust in the presence of water. So if you take iron nails and you wet them and you expose them to air as well, they'll rust. That's actually a chemical reaction. You convert some of the iron into iron oxide, so iron and oxygen. We can also say that in order to observe a chemical property, the identity of the chemical must change, as well as some of or all of its characteristics. Paper that burns no longer looks like paper, since the results of burning paper is mostly water, carbon dioxide, heat, and light. In other words, when you burn paper, you light it up. That's a chemical reaction. It's actually oxidation of paper, which is mostly made out of cellulose. And the product of that is carbon dioxide, water, and you have heat and light, so energy is being released. Once that chemical reaction is done, converting the paper into those other products, you can no longer write on it. It doesn't have the same properties that it did before. Chemical change, number 17, chemical change or chemical reaction. It's a change in one or more substances that are converted into one or more other substances. The characteristics of the substances produced are not the same as the starting substances. Properties are different. In other words, the density is going to be different. It's going to react differently. So it's no longer the same. So number 18, reactants, one or more substances that undergo a chemical reaction. So the iron and the oxygen would undergo the reaction. And number 19, products, one or more substances that result from the chemical reaction. In this case, you have one. Would be their products. Light and heat are types of energy and would not be either a product or a reactant. How do you know that a chemical reaction has occurred? There's actually one or more indications that you would actually see. So first indication is A, evolution of heat and light. So when I burn paper, I produce heat, but I also produce light. Those are two examples of some evidence that would indicate that a chemical reaction would occur. The production of gases. So not all chemical reactions, because if I boil water, that's not a chemical reaction. That's a phase change, a physical change. But some substances, when they go through a chemical reaction, they produce a gas. So think of baking soda and water. If I add baking soda and vinegar. If I add baking soda to vinegar, you're going to see a lot of bubbles produced. That's an example of a chemical reaction. There's a gas, carbon dioxide, produced as a byproduct of the reaction between baking soda and vinegar. Okay? So some reactions produce bubbles, An example may experience are bubbles produced when mixing baking soda and vinegar. And yep, so not everybody realizes that's a chemical reaction. A formation of a precipitate. So other chemical reactions may form a solid material that either floats or falls to the bottom of a liquid. All right, so you actually see you could have a liquid. The liquid might not be clear, but you'll produce a spot with couple liquids, and you would see the production of a solid. And a solid might be a different color, but it's liquid. Now, if you look at chemical reactions can be either exothermic or endothermic. Chemical reaction is a change. It could be a change in phase as well. But if I look at burning paper, that's an exothermic reaction. So exo means out, therm is heat. So it's release of heat. When I burn paper, it's a chemical reaction, and in that process, I release heat. So ice pack containing ammonium nitrate and water can undergo an endothermic reaction when the ammonium nitrate dissolves in the water. So this isn't a chemical reaction. This is just a dissolving of a solid liquid. But when you do that, it gets cold. Why does it get cold? Because it's absorbing heat. So when you feel anything object that feels cold, why does it feel cold? Because it's actually taking heat away from your skin. It's an endothermic change that's occurring. Okay? I'm not going to finish that in this unit. I have class. The classification of matter. You can have mixtures of four substances. Mixtures of four substances. So a mixture, what is a mixture? It's a combination of two or more kinds of matter, each of which retain its own composition and properties. The individual kinds of matter can be separated by physical means. Okay, and we'll talk about the two types of mixtures. You have a homogeneous mixture. Sorry, heterogeneous mixture. So you have a heterogeneous mixture and a homogeneous mixture. A heterogeneous mixture is a mixture in which the composition is not the same throughout. I like using the example of alphabet soup. If you've ever had alphabet soup, you know that if I take a spoon out of the liquid, I'm probably going to have different letters in it. Right? So the letters are not evenly spread out. The composition is going to be different. In other words, going to be different letters in different parts of the soup. So that would be a heterogeneous mixture. A homogeneous mixture composition is exactly the same throughout. If I dissolve sugar and water, they dissolve. You can't see them anymore, but they spread out evenly. So after you mix it together, they spread out evenly. So no matter where in the body of water you add, you check to see how much salt there is after I mix it in there. It's going to have the same amount.